You know, when you step outside on a really clear, dark night, far away from city lights, and you just look up, it usually looks like a completely random scattering of glowing dots, like someone just spilled glitter on this massive black canvas.
Right, yeah. It's objectively beautiful, but to most of us today, it feels, completely chaotic. There's no apparent order to it at all.
Exactly. And I think we see it as this beautiful abstraction,
Yeah.
like a static picture.
And that is largely because modern life has, well, it's completely severed our daily physical dependence on tracking the sky. I mean, if you want to know what time it is, or when to plant crops, or when the tide is coming in, you look at a screen. You don't look up.
Yeah, we totally lost that connection. But when you dive into the minds of early astronomers, that exact same sky wasn't chaotic in the slightest. I mean, it wasn't a static picture, and it certainly wasn't abstract. It was an incredibly intricate, constantly moving, perfectly tuned clockwork mechanism.
It was a machine. Every single point of light had a predictable path, a specific speed, and a very strictly defined mathematical relationship to the observer standing on the ground.
Which is wild to think about without telescopes. So today, our mission in this deep dive is to unpack the foundational texts of traditional Indian astronomy and mathematical astrology. These are documents formulated literally thousands of years ago.
And they map the universe with a level of precision that comes down to decimals of a second.
Decimals, it's crazy, all calculated without modern tech. So our goal today is to reconstruct that exact mathematical model for you. We are going to map the specific points where ancient human observation meets precise cosmic mechanics.
And to really understand the gravity of these texts, you have to look at how this ancient culture structured knowledge itself. The source material isn't just like an observation log.
Right.
Astronomy and astrology, collectively known as Jyotisha, were considered one of the core foundational disciplines required to just understand existence. It's one of the 6 Vedangas.
Yeah, right up there with phonetics, rituals, etymology, meter, and grammar. It's foundational. And there is a beautiful, almost poetic analogy from the text that frames this perfectly.
Kakalparush?
Yes. The ancient texts, the Vedas, are considered to represent a vast cosmic being, the Kalpurush. And Jyotisha, this intense mathematical science of charting the stars and planets, is regarded as the eye of this cosmic being.
The metaphor is just profound when you unpack it. I mean, an eye is the organ of perception. It is the discipline that allows a complex system to actually see and measure the physical reality of time and space around it.
Right, otherwise you're just wandering in the dark.
Exactly. Without the mathematics of the stars, the cosmic being is essentially blind to its own surroundings.
Yeah.
It cannot navigate. It cannot anticipate.
And that is the exact capability we want to give you listening right now. Over the course of this deep dive, we are going to comprehensively unpack these ancient mathematical models. We want to give you that eye, to look at the universe not as random dots of glitter, but as this majestic, interlocking, entirely legible mechanism.
But to look out at the universe and make sense of it, you first need a solid anchor. You have to start at the very center of this clockwork, the Earth.
Which makes sense. You have to know where you're standing.
Right. Before you can map the heavens, you have to establish the geometry of the ground you are standing on. You need a structural blueprint. And the texts lay this out with striking precision.
Okay, let's unpack this. Let's lay down the foundational numbers the text gives us about the Earth's motion. First up, rotation. The Earth completes one full rotation on its axis in 23 hours and 56 minutes.
And we'll get into the fascinating mechanics of why that isn't a flat 24 hours in just a moment.
Yeah, that part blew my mind. Second is revolution. The Earth completes one orbit around the Sun in 365.25 days.
That fractional 0.25 is the mechanical reality that forces us to use leap years, to catch the calendar up.
Right. And finally, the tilt. The Earth leans on its axis at an angle of 23 degrees and 26 minutes.
Those 3 variables, the 23-hour 56-minute spin, the 365-day orbit, and that 23-degree tilt, those are the hidden engines driving every single cosmic event we are going to discuss today.
But knowing the Earth is moving isn't enough, right? I mean, to track anything systematically, you need a coordinate grid mapped onto the sphere of the Earth itself.
Exactly. And the text outlines a geographical grid that actually mirrors what we use today. We start with the equator, or Bhumadhya Rekha.
Right.
This is the imaginary baseline, situated exactly 90 degrees perpendicular to the Earth's tilted axis. It slices the Earth into perfectly equal northern and southern halves. So if you stand on the equator, you are sitting at 0 degrees latitude.
Okay, so that gives us horizontal slices, but you need vertical slices to create intersecting points. like a checkerboard. The text points to a prime meridian, the Yamyota Rekha.
Today, the globally accepted 0-degree longitude line passes through the Royal Greenwich Observatory near London. Any location lying directly on that line, from the North Pole down to the South Pole, sits at 0 degrees longitude.
And if you trace that 0-degree meridian all the way around to the complete opposite side of the globe, you hit the 180-degree meridian. That exact opposite boundary is what we now call the international dateline.
So we have an invisible, mathematically perfect grid wrapped around the Earth, north, south, east, west, entirely mapped out.
Okay, so we've got our Earth mapped. But here is where the source material asks us to do a massive spatial leap. It tells us to take this earthbound grid and forcefully project it outward into the void of space.
Yes. We are entering the concept of the celestial sphere. This is the universe modeled purely from the observer's standpoint.
Right.
Imagine an observer sitting at the exact core of the Earth. If you take the Earth's surface and blow it up, just expanding it infinitely in all directions into the cosmos, you create a massive, imaginary sphere encasing our entire reality.
Okay, let's unpack this visually because it's a bit abstract. It's like the Earth is a tiny, glowing light bulb sitting suspended in the exact center of a giant, infinite paper lantern.
I like that.
And if you draw dark grid lines on that light bulb, the light is going to cast shadows outward, projecting those exact same grid lines onto the inside surface of the massive paper lantern.
That physical projection is exactly how the ancient mapping works. If we take the Earth's North Pole and South Pole, the invisible rod our planet spins on, and we extend that rod infinitely straight up and straight down until it pieces our imaginary paper lantern, we establish the celestial North Pole and the celestial South Pole.
Got it. And if we take the Earth's equator, that 0-degree felt around our planet's waist, and we stretch it outward like a rapidly expanding flat disk until it hits the lantern, we create the celestial equator.
Precisely. So just like the Earth's equator divides our physical planet in half, the celestial equator divides this infinite void into the northern celestial hemisphere and the southern celestial hemisphere.
Yeah. But I have to stop and ask a fundamental question here. Why go through the trouble of stretching a 2D grid onto the universe? Space is three-dimensional. It has infinite depth. Wrapping graph paper around the universe feels like a massive mathematical simplification. Doesn't projecting a flat grid inherently distort the reality of deep space?
What's fascinating here is that, yes, it does distort physical reality, but it perfectly models observational reality. We have to remember the strict perspective of the ancient sky watcher here.
Right, they don't have spaceships.
Exactly. We project a grid outward because, from the biological limitations of human sight on the ground, the sky acts exactly like a dome. We do not possess built-in depth perception for infinity. When you look up, a star that is 10 light-years away and a star that is 1,000 light-years away appear to be pinned to the exact same flat black ceiling.
We literally cannot see the z-axis of the universe.
We cannot. So projecting our Earth grid onto that perceived inner dome of the paper lantern is the ultimate tool for localization. It allows you to track planetary movements relative to your own specific location on the ground. Space has no inherent up, down, left, or right.
Right, it's just a void.
Exactly. If you don't project the equator and the poles into the sky, you have zero mathematical anchor. You can't say, oh, the moon is moving higher, because higher only means something if you have a baseline drawn on the sky to measure it against.
We are essentially taking our earthbound physics and forcefully imposing them on the heavens just so we have a language to describe what we're seeing. That makes total sense.
It's extremely pragmatic.
So we have established our light bulb, we have built the infinite paper lantern surrounding it, and we've drawn our celestial grid on the inside of it. But the universe isn't static. Things move. And that takes us directly from the architectural blueprint into the raw mechanics, the geometry of time, distance, orbits, and speeds.
Right, and the first mechanical rule we have to acknowledge in traditional Indian astrology is that it utilizes a geocentric system.
Meaning the Earth is placed at the absolute, unmoving center of the universe, and all other celestial bodies, including the sun, revolve around it. Now, any listener who passed middle school science is going to immediately flag this. We know definitively that the solar system is heliocentric. The Earth orbits the sun.
They will flag it, yes. But the ancient astronomers were tracking observational realities, not necessarily deep space physical realities. For the mathematics of tracking exactly where a planet will appear in the sky over your village tonight, you must place the observer at the center of the geometry.
Ah, okay.
If you were trying to calculate the angle of a star from a hilltop, building a model where the sun is the center is incredibly mathematically cumbersome. The geocentric model is a pragmatic observational truth required to do the math from the ground.
It's a localized frame of reference. Keeping that strict Earth-centered view, we have to map the most dominant object in the sky, the sun. From our vantage point on the ground, the sun carves a very specific, apparent path across the sky throughout the year. The text calls this path the ecliptic, or the Ravi Marg. It's also known as the Krintivrit.
And mathematically, the text acknowledges this path is the inverse reflection of Earth's actual orbit around the sun. But traced onto our giant paper lantern, it forms a crucial fixed circle called the ecliptic.
And once you have established the ecliptic, the sun's exact track, you unlock the ability to measure time with astonishing, almost terrifying precision. The source material makes a vital distinction between different frameworks of time, specifically separating solar time from sidereal time.
This brings us back to the Earth's rotation. If you ask anyone on the street how long a day is, they will say 24 hours. But earlier, we noted the text states the Earth rotates once on its axis in 23 hours and 56 minutes. That is a sidereal day. The time taken to complete one exact 360-degree spin relative to a fixed, distant star in the background.
But why is there a 4-minute discrepancy between spinning around once and our normal 24-hour day?
Because a normal 24-hour solar day is defined as the time it takes for the sun to return to the exact same spot in the sky. But remember, our two engines of motion, the Earth is spinning like a top, but it is also moving forward along its massive orbit around the sun.
Oh, right. It's doing both at once.
Exactly. Imagine you are standing on a track, spinning in a circle, and the sun is a lamp in the middle of the track. If you spin exactly 360 degrees, you are facing the exact same direction you were a moment ago.
Yeah.
But because you also took a step forward along the curved track while you were spinning, the lamp in the middle is no longer directly in front of you. The angle has changed. To get the lamp perfectly centered in your vision again, you have to spin just a tiny bit further.
And that extra little fraction of a spin takes 4 minutes.
Exactly. So the physical 360-degree rotation, the sidereal day, is 23 hours and 56 minutes. The time it takes to face the sun again, the solar day, is 24 hours.
Without modern technology, identifying and mathematically isolating that 4-minute orbital drift just by staring at the sky is a monumental intellectual achievement.
It really is. And they applied this exact same sidereal isolation to the moon. The text defines the sidereal month. This isn't just the time from one full moon to the next. It is the exact mechanical time it takes for the moon to complete one full 360-degree orbit around the Earth relative to a distant, fixed background star.
And the text provides a figure for this that is honestly hard to fathom. It calculates the sidereal month at exactly 27 days, 7 hours, 43 minutes, and 11.6 seconds.
Decimals of a second. I mean, the level of continuous multi-generational observation required to average out the data to arrive at 11.6 seconds is staggering. It requires hundreds of years of meticulous record-keeping.
It's just mind-blowing. As these generations of astronomers plotted these hyper-specific orbits, the data revealed another crucial physical reality. These orbits are not perfect circles drawn with a compass. They are elliptical.
Right.
They are stretched out, slightly oval-shaped. This means the distance between celestial bodies physically changes depending on where they are on the track.
Let's apply this elliptical reality to the Earth and the Sun. Because our orbit is stretched, there's a specific moment when the Earth is physically closest to the Sun and a moment when it is farthest away. The point on the track closest to the sun is called perihelion, or upsoar.
And the text notes that every single year, around January 3rd, the Earth hits perihelion. It is as close to the sun as it physically gets. The opposite extreme, the point where the Earth is furthest from the sun, is called aphelion, or apsoar. And we hit that furthest marker around July 4th. I want to sit with this for a second because the perihelion date usually breaks people's brains when they first hear it. We are physically closest to a gigantic burning nuclear furnace on January 3rd. January. In the Northern Hemisphere, where these texts were written, January is the dead, freezing center of winter. Wait, if we're closest to the fire, why are we freezing?
It feels completely contradictory to human logic. You naturally assume proximity equals heat.
But this seemingly contradictory data point proves something profound about the mechanics of our planet. It proves definitively that our distance from the sun does not dictate our seasons. If distance were the driver, January would be boiling hot and July would be freezing.
Exactly. Instead, this proves that the 23-degree, 26-minute tilt of the Earth's axis, the third engine of motion we established, is the sole dictator of the seasons. During January, the northern hemisphere is tilted away from the sun. So even though the planet as a whole is millions of miles closer to the heat source, the sunlight is hitting the northern half of the globe at a glancing, highly indirect angle. The energy is spread out and weakened by the atmosphere.
The geometry of the tilt entirely overrides the proximity of the orbit. That is so cool. And we see these elliptical extremes with the moon as well, right?
We do. The point in the moon's orbit closest to Earth is perigee, or Bhumi niche, bringing the moon to about 356,400 kilometers away. The farthest point is apogee, or Bhumi uch, pushing it out to 406,700 kilometers. That is a variance of roughly 50,000 kilometers every single month.
That massive stretching and shrinking of distance leads to a critical rule in the text, the apogee and perigee speed concept. In the traditional terminology, this is the principle of Shikrak and Mandoch. The text clearly states that a planet does not travel at a constant speed. Its velocity violently fluctuates based on its distance from whatever it is orbiting.
And the text asserts that a celestial body's speed hits its absolute maximum at the perihelion, or perigee, the point of closest approach. This velocity peak is called shigroch. Conversely, its speed drops to its absolute minimum at the aphelion or apogee, the furthest point out. This slow point is Mandoch.
I love that they deduced this because it perfectly models the invisible force of gravity long before gravity was codified as a mathematical law by Newton. I mean, think about the physical mechanism here. When the Earth gets close to the massive gravity well of the sun at perihelion, that gravitational pull acts like a slingshot.
Exactly.
It violently accelerates the planet, whipping it around the tightest part of the curve at maximum speed shigroch. If the Earth didn't speed up, the gravity would overpower its forward momentum, pull it straight into the sun, and incinerate it.
It's a cosmic survival mechanism. And as the planet slingshots outward toward the far end of the oval, the aphelion, it is fighting against that gravitational tether. The sun is pulling it backward, so it naturally mathematically decelerates, losing speed just like a pendulum slowing down as it reaches the absolute peak of its swing.
Right.
When it hits Mandoch, its slowest point, the gravity wins, pulls it back inward, and the cycle accelerates all over again.
It is a phenomenal accelerating and decelerating orbital dance, and the fact that they map the precise rhythm of that dance is incredible. So we have tracked the exact singular path of the sun, the ecliptic line, but we know the other planets in our solar system don't travel single file, perfectly hidden behind the sun on that exact string. What happens when we widen that path? We get the most famous, heavily trafficked belt in the entire night sky.
Right. We transition from the single wire of the ecliptic to the broad, multi-lane highway of the zodiac known as the Pachakra.
The text explains that if we take that single ecliptic line drawn on our celestial dome, and we extend a boundary 8 degrees to the celestial north and 8 degrees to the celestial south, we carve out a 16-degree wide imaginary belt wrapping around the universe.
And you might ask, why 16 degrees? Because the ancient astronomers observed that the orbits of the other planets, Mercury, Venus, Mars, Jupiter, Saturn, are all slightly tilted relative to the Earth's orbit.
They aren't on a flat plate.
Exactly. They don't run on the exact same flat plane, but their tilts are relatively shallow. They wander slightly above or below the sun's exact path, but they never wander further than 8 degrees in either direction.
So this 16-degree belt contains all planetary movement. This is the zodiac, and it is the foundational bedrock of traditional Indian astrology.
The zodiac is the grand stage. You have this sweeping 16-degree band encircling the observer, and against the background stars of this specific band, the entire complex choreography of the solar system takes place. But to measure movement along a circular belt, you face a geometric problem. Where does the circle start? You need a 0 point, a starting line.
Enter the vernal equinox, or the first point of Aries, traditionally known as the Vasant Sampat Bindu. To visualize this, let's bring back the 2 giant circles we drew on our paper lantern. We have the celestial equator, the infinite projection of Earth's flat waistline, and we have the ecliptic, the tilted path of the sun.
Because the Earth is tilted 23 degrees, these 2 giant hula hoops are tilted relative to each other. If you place 2 tilted rings inside a sphere, they are mathematically forced to intersect at exactly 2 points.
One of those 2 precise intersection points is the vernal equinox. Around March 20th every year, The sun is traveling along its tilted ecliptic path, moving up from the southern celestial hemisphere. When it hits that intersection point, it physically crosses over the celestial equator into the northern hemisphere. That exact fraction of a second of crossing is the first point of Aries.
And the physical ramification of that geometric crossing is profound on the ground. At the exact moment of the equinox, the sun's rays are hitting the Earth's physical equator at a perfectly straight 90-degree angle. Because of this perfect alignment, day and night become equal everywhere on the planet. 12 hours of light, 12 hours of darkness. It is a moment of total, global cosmic balance.
It is the most elegant, naturally occurring starting point you could ask for in a mathematical system. You anchor your 0-degree starting line to the moment of perfect light-dark balance.
But of course, the universe refuses to make it that easy. There is a grand complication, a massive, slow-moving wrinkle in the math that the ancient skywatchers eventually noticed, which completely threatened their entire system. The text points out that the vernal equinox, this perfectly balanced starting line, is not actually bolted to the background stars. It is moving.
Here's where it gets really interesting. The text introduces the mechanism known as the precession of the equinoxes. It records that the point of the vernal equinox is slowly sliding backwards, moving westwards along the ecliptic at a rate of roughly 50.29 arc seconds every single year, measured against a fixed star.
I really want to emphasize how wild this is. 50 arc seconds a year is microscopic. It is a fraction of a single degree. An individual astronomer would never ever notice this shift in a human lifetime of staring at the sky.
But if you belong to a continuous, multi-generational civilization keeping rigid astronomical records for hundreds or thousands of years, the math starts to pile up. If your starting line shifts backwards by 50 seconds a year over 2,000 years, that drift accumulates to roughly 30 degrees. 30 degrees is the exact width of one entire zodiac sign.
The mechanics behind this drift are tied to the Earth itself. The Earth isn't just spinning, it's wobbling. Like a spinning top that is starting to lose momentum, the Earth's 23-degree axis slowly traces a circle in space over roughly 26,000 years.
Wow.
As the axis wobbles, the tilt shifts, which means the celestial equator shifts, which means the exact point where it intersects the sun's path. The vernal equinox slowly slides backward along the highway.
The implication of this is staggering. It means the sky we look up and see tonight is physically not in the same position as the sky the ancient texts originally mapped. The entire starry backdrop of the universe has slid one full zodiac sign out of frame.
And this geometric reality forces a structural crisis in how you map the heavens. If your starting line is moving away from the stars, which one do you trust? The text clearly defines two divergent mathematical systems that arise to solve this shifting reality.
Okay, lay them out for us.
First, you have the science system, which translates to the tropical moving zodiac.
Yeah.
The logic of the science system is pragmatic. We don't care if the background stars have drifted millions of miles. The vernal equinox dictates our physical seasons on Earth. Therefore, the exact moment of the equinox is always 0 degrees Aries, regardless of what stars happen to be behind it.
So the science system is entirely tethered to the Earth's seasonal cycle. March 20th is the start of the zodiac, end of story. The physical stars don't matter.
But then you have the opposing framework, the Narayan system or the sidereal fixed zodiac. The logic here is we are tracking the actual cosmos. The physical stars are our anchor. So the Narayan zodiac locks its 0-degree starting line to a fixed, unmoving point in deep space, completely ignoring the sliding vernal equinox and the Earth's seasons.
You essentially have two different maps of the exact same 16-degree highway. One map is a transparent overlay that slides slightly backwards every year to keep perfect time with Earth's seasons. The other map is bolted permanently to the distant stars. If you overlay those two maps today, thousands of years after they were first drawn, they don't line up at all. They are an entire zodiac sign out of phase.
And that misalignment requires a mathematical bridge, which the text defines as the concept of ayanamsha. Ayanamsha is the precise numerical difference between the starting point of the fixed Narayan zodiac and the current moving vernal equinox of the Saiyan zodiac. It is the quantifiable value of how far the two maps have drifted apart.
The text notes a standard anchor used for this calculation called the Chitrapaksha Ayanamsha, which locks the fixed calculation to the position of a specific star, Chitra, known in the West as Spica.
If we connect this to the bigger picture, the intellectual flexibility here is what is truly remarkable. These astronomers realized the foundational geometry of their universe was slowly rotating beneath their feet. Instead of throwing their hands up and abandoning the system, they mathematically quantified the wobble.
Right, they didn't panic.
The invention of Ayanamsha is essentially a software patch for a shifting universe. It allows both the seasonal calendar of the science system and the stellar calendar of the Nairean system to mathematically coexist, communicate, and translate into one another.
It's like discovering the foundation of your massive stone observatory is slowly sliding down a hill. And instead of panicking, you invent a complex gyroscopic suspension system that keeps the telescopes perfectly level while the Earth moves beneath them.
That's a great way to put it.
So we have constructed our celestial grid. We've mapped the 16-degree highway of the zodiac. We've accounted for the 26,000-year wobble of the Earth and the shifting background of the stars. But the sky isn't just predictable, slow-moving gears. It's also full of sudden, violent, physical intersections. Let's talk about what happens when things crash into this mathematically perfect grid. We were talking eclipses, rogue comets, and burning space debris.
The most mathematically rigorous and visually terrifying of these intersections are the eclipses, or Grayan. The text provides the fundamental, unsentimental mechanic. An eclipse is simply a localized shadow. It occurs when one celestial body is partially or fully obscured by another. Specifically, it requires the sun, the earth, and the moon to align in a perfectly straight three-dimensional geometric line.
And the timing of these shadows is predictable based on the phases of the moon. The text codifies that a solar eclipse where the moon's physical body blocks the sun's light from reaching Earth can only occur near a new moon when the moon is between us and the sun. A lunar eclipse where the Earth casts a massive shadow over the moon only happens near a full moon when the Earth is in the middle.
But an obvious question arises. We have a new moon and a full moon every single month. Why don't we have eclipses every 2 weeks?
Oh, right, that would be chaotic.
This goes back to the 16-degree zodiac highway. The moon's orbit around the Earth isn't perfectly flat relative to the Earth's orbit around the sun. It is tilted by about 5 degrees. So most months, the new moon passes slightly above or slightly below the sun from our perspective. An eclipse can only happen when the moon crosses the exact mathematical center line of the ecliptic, the nodes. The text tracks these nodes obsessively.
Moving outward from the moon, the text categorizes the other physical inhabitants intersecting our system. It defines asteroids as minor planets, noting their massive concentration in a belt situated between Mars and Jupiter. And then we have the dramatic rogue visitors comets, or Dhumketu.
Yes, Dhumketu.
The text describes them physically as being formed of ice, dust, and frozen gas. They are categorized as temporary members of the solar system, arriving on vastly stretched elliptical orbits that enter our space only after fixed, predictable intervals. I love the traditional descriptive name for them used in the text, tail stars.
Tail stars is an incredibly accurate observational label. It describes exactly what happens mechanically. As this frozen ball of ice and dust clumps toward the perihelion, getting closer to the immense heat of the sun, the solar radiation begins to violently boil off the ice, creating a massive glowing trail of vaporized gas pointing away from the heat source.
The meticulous categorization continues with how the text defines the smallest space debris interacting with Earth. It actually breaks down the violent life cycle of a meteor into 3 distinct physical phases.
This part is fascinating.
Phase 1, the object is just drifting in the void. The text calls these small celestial bodies present in the vacuum between planets meteoroids, or Ulka. It notes they are too microscopically small to track or study individually. They are essentially grains of cosmic sand or loose rock.
Phase 2 triggers when one of these microscopic Ulka physically intersects with Earth's trajectory. As the meteoroid plummets into the Earth's atmosphere, the Earth's massive gravity accelerates it to immense speeds. This hyperacceleration forces the rock to slam into the dense gases of our atmosphere, creating extreme, violent friction. The rock physically ignites.
Whoa.
When it is visible as a burning streak across the night sky, its classification changes to a meteor shower or a meteor fall, termed Ulkapot.
It is essentially a cosmic rebranding. It's an Ulka while it's just hanging out in space. It becomes an Ulkapot the moment it hits the atmosphere and puts on a light show. And it's basically a spacecraft hitting re-entry without a heat shield.
Exactly. And finally, phase 3. If the rock is dense enough to survive the atmospheric fire without entirely vaporizing, the remaining fragments violently impact the Earth's surface. These surviving physical rocks on the ground are given their final title, Ulkshum on the ground.
Ulkashum. So we have Ulka, Ulkapot, and Ulkashum.
This 3-tier classification highlights something vital about the intellectual posture of the source material. In many ancient cultures, a shooting star was viewed with superstition. It was a terrifying omen, a fiery disruption of the natural order sent by angry gods.
Right, people panicked.
But here, they are categorized meticulously based on their changing physical states and locations. The text strips away the panic. It approaches a flaming rock falling from the sky with the exact same systemic mathematical rigor it applies to calculating the lunar nodes for an eclipse. It is an unrelenting attempt to rationally organize every single phenomenon in the sky.
Which brings up a really fascinating transition. We just talked about physical rocks hitting the physical ground, tangible, violent events. But the ancient astronomers spent massive amounts of computational energy tracking events that weren't physical at all. Sometimes the most dramatic, complex events tracked on the zodiac highway were purely optical illusions. Illusions that only exist because of our specific moving vantage point on Earth.
To untangle these complex optical illusions, the text details 3 highly specific coordinate systems used to lock onto a heavenly body's apparent position. We've touched on elements of these, but they are formalized as follows. First, the ecliptic system, which provides celestial longitude and celestial latitude.
If we use a modern city metaphor, this is like navigating using the major highway system. It maps a planet's location strictly based on how far along the sun's 16-degree zodiac highway it has traveled, which is longitude, and how many degrees it has drifted into the shoulder lanes, which is latitude.
Perfect analogy. Second, the equatorial system, which provides declination and right ascension.
Sticking with the city map, this is the strict grid of avenues and streets. Right ascension measures the east-west avenues along the celestial equator, and declination measures the north-south streets, tracking how far a planet is towards the celestial north or south pole.
And third, the alt-azimuth system, which provides altitude and azimuth.
This is your absolute hyper-local, you are here pin. Azimuth is just compass direction is the planet north, south, east, or west of where I'm standing right now. Altitude is how high I have to tilt my neck up from the horizon to look at it.
By heavily layering these 3 independent coordinate systems, ancient astronomers could precisely track and mathematically predict the most perplexing line-of-sight illusion in the entire night sky retrograde motion.
Retrograde motion. This is when a planet appears to completely stop its normal forward movement across the sky, turn around, move backward for a few weeks or months, and then stop again, turn around, and resume its forward path. To an early skywatcher, this must have been a system-breaking observation. The planets are supposed to follow the divine mathematical rules. They are on a track. Why is Mars suddenly pulling a U-turn and driving backward into oncoming traffic?
It creates a massive geometric headache. The text provides the mechanical rules for when this illusion occurs, and it fundamentally divides the planets into 2 separate groups to explain the different mechanics, the inner planets and the outer planets.
The inner planets are Mercury and Venus, the ones operating on smaller, tighter tracks between Earth and the Sun. The text states that these inner planets go into apparent retrograde when they are positioned ahead of the Sun from our line of sight. It gives exact mathematical bounds for this illusion. Mercury appears to move backward when it is positioned between 15 degrees and 27 degrees from the Sun. Venus goes retrograde when it hits between 27 degrees and 47 degrees from the Sun.
But the mechanics flip for the outer planets, Mars, Jupiter, and Saturn, which orbit on massive tracks outside of Earth's path. The text explains that because their orbits are vastly larger, their orbital speeds are much slower than Earth's. They appear to go retrograde when our faster-moving Earth catches up to them and laps them on the inside track.
This is the classic highway passing illusion. Imagine you are driving 70 miles an hour in the fast inside lane of a highway. You approach a slower truck doing 50 miles an hour in the outside lane next to you. As you pull up behind them, they are clearly moving forward. But the exact moment you pull alongside them and pass them, if you look out your passenger window, the slower truck appears to be sliding backward relative to the frame of your window. The truck isn't actually in reverse. Your faster velocity is just creating a visual trick of perspective.
That is the exact mechanism, and the text provides the precise geometric angles for when this celestial passing lane illusion triggers. It states outer planets will appear retrograde when they are positioned 120 degrees to 240 degrees away from the Sun, or, translated into astrological terminology, when the outer planet sits in the 5th, 6th, 7th, or 8th house relative to the Sun's position.
So they mapped the exact mathematical geometry of an optical illusion. But the visual tricks get even more intense when we talk about planetary invisibility. The text details a phenomenon called planetary combustion. Despite the dramatic name, this isn't a planet physically catching on fire. Combustion happens when a planet's orbit takes it too close to the Sun strictly from our line of sight on Earth. The planet completely disappears from the night sky, entirely swallowed by the overwhelming, blinding glare of the sun.
And, true to its rigorous nature, the text doesn't just broadly state the planet gets hidden. It calculates and provides the exact, approximate angular limits of the glare. It defines precisely how many degrees away from the sun a planet must be to pierce the light and become visible again.
And those limits change, right?
They do. These limits fluctuate based on whether the planet is in direct motion or retrograde motion, because retrograde changes the planet's apparent speed and its angle of attack relative to the sun's glare.
Let's run through the mathematical limits for direct motion, because the contrasts are wildly revealing about the physics involved. The moon becomes combust, or invisible, when it gets within 12 degrees of the sun. Mars goes combust at a massive 17 degrees out. Mercury disappears at 14 degrees. Jupiter at 11 degrees, Venus at 10 degrees, and Saturn at 16 degrees. And if Mercury and Venus happen to be in their retrograde U-turn, their limits shift. Mercury disappears at 12 degrees and Venus at 8 degrees.
These varying angular degrees of invisibility are not arbitrary numbers. They are a direct physical result of the differing sizes, reflectivity or albedo, and distances of the planets involved.
Oh, that makes sense.
Take Mars and Venus as a contrast. Mars is a relatively small, dusty red rock that isn't incredibly reflective. Because its light is weak, it is overpowered by the sun's massive glare. Much sooner it vanishes when it is still 17 degrees away. Venus, on the other hand, is encased in highly reflective white clouds. It is the brightest object in the sky after the moon.
Right, it's piercing.
Because its light is so intensely bright, it can survive much deeper into the glare, getting as close as 10 degrees before its light is finally drowned out.
It's a battle of lumens, and the duration of this invisibility is shocking. The text lists exactly how long these massive planets are hidden from human eyes. The moon is only swallowed by the glare for about 2 days. That's the dark phase of the new moon. Mercury is gone for 11 to 20 days. Jupiter, the largest planet in our solar system, is entirely hidden from the Earth for roughly 28 days. Saturn is gone for 57 days. Venus for 53 days. But look at Mars. The text states Mars is combust for 118 days. The planet completely disappears from the sky for nearly a third of a year. Why is Mars hidden for so much longer than Jupiter, which is further away?
This raises an important question, and it is entirely due to the geometry of the orbits. Mars orbits just outside the Earth. It is moving relatively fast, but slower than us. When Mars slips behind the sun from our perspective, our orbital speeds are similar enough that we stay locked in that blind spot for a long time.
Ah, so we're just cruising along with it in the blind spot.
Exactly. Mars is lingering in the glare. Jupiter moves so slowly in its massive outer orbit that Earth zips past the blind spot much faster, uncovering Jupiter in just 28 days.
Wow.
What this highlights is the tremendous, almost terrifying mathematical faith these early astronomers had to have in their models. For 118 days, Mars is completely invisible. You cannot verify its position with your eyes. You have to rely purely on your math, running the calculations in the dark, trusting that when 118 days pass, Mars will emerge from the glare exactly where your equations predicted.
That is a staggering level of trust in the unseen math. And speaking of Mars, the planet of war, that leads us directly to the final, most dramatic line-of-sight illusion detailed in the text Planetary War, or Graha Yuddha.
Graha Yuddha.
The text defines planetary war as an event occurring when two planets come within less than 1 degree of each other in the sky. To the naked eye, they appear to be physically colliding, merging into a single point of light, fighting for dominance of that space. The text dictates that the planet with the lower degree, meaning it has a slightly closer longitude, is considered the absolute winner of the war.
It adds an addendum, too. If a planet comes within 1 degree of the sun, participating in a Graha Yuddha with the sun itself, it is considered completely overpowered. It becomes extremely weak and is unable to yield positive results in the predictive astrological framework.
So, what does this all mean? Hold on, I need to represent the skeptical modern listener here. I have to push back on the terminology and the logic. We are calling it a war and assigning victories. But just like retrograde motion, this is entirely an optical illusion, right? Jupiter and Mars might look like they are smashing into each other, but in three-dimensional reality, they are hundreds of millions of miles apart. One is simply passing in front of the other strictly from where we are sitting on Earth. How does an optical illusion dictate a winner?
You are absolutely correct on the physics. Physically, there is no collision. The war is purely an event of angular proximity, a traffic jam on the flat celestial dome we built inside our paper lantern earlier.
Right.
But within the philosophical and mathematical framework of this ancient science, that line-of-sight proximity is profoundly structurally meaningful. Think back to the angular limits of combustion we just analyzed. A planet is hidden by the sun purely because their light merges in our eye. In a Graha Yuddha, when two planets merge within a single degree, their distinct lights physically blend together from the observer's perspective.
So the logic is, if their light merges in our eye, their influence merges in the system.
Exactly. The text treats the observer's vantage point as the anchor of reality. Calculating a planetary war requires immense computational skill to anticipate an optical collision between two moving bodies down to a fraction of a single degree of longitude.
It is an obsession with exactitude, which brings us to a crucial pivot point in our deep dive. With all these incredibly intricate, mind-bending mathematical rules, the 26,000-year precession wobble, the angular limits of the sun's glare, the passing lane illusions of retrograde, how did the ancient scholars actually package all this massive data? How did they take centuries of celestial geometry and organize it into something a human being could use? This brings us to the ultimate synthesis of the text, the three pillars of astrological science.
The structure the text lays out is incredibly systematic. It divides the entire sprawling discipline of Jyotisha into two main overarching buckets. First, you have mathematical astrology, or Ganit Jyotish. This is the pure, unsentimental study of the geometry, position, and movement of planets and constellations. Every single technical mechanism we have discussed for the past hour, the grid, the orbital speeds, the degrees of combustion, the eclipses, falls strictly into Ganit Jyotish.
It is the raw, unadulterated data of the universe.
Precisely. Then you have the second bucket, predictive astrology, or Phalet Jyotish. This is the application phase. It is the study of the supposed effects of those geometric planetary movements on the living and non-living world on Earth.
And to apply this data practically, the text breaks the entire science down into three specific branches known as skandhas. Branch number 1 is the Ganit skandha. As we established, this is the purely mathematical foundation. It calculates the 16-degree zodiac highway, tracks the 50.29-second shift of the equinox, and predicts the exact timing of eclipses. It is the engine.
Branch number 2 is the Samhita skandha. This branch takes the raw data from the Ganit engine and scales its predictive models to the absolute macro level. The text describes Samhita as a collection of principles based on planetary movements used to predict global, large-scale events. It attempts to map celestial alignments to natural disasters, shifting seasonal weather patterns, and major political, economic, and social changes within nations.
And finally, branch number 3 is the Hora skandha. This takes that exact same mathematical data and scales it all the way down to the hyper-micro level. Hora is predictive astrology based on an individual human's specific time and place of birth, charting the sky at that exact moment to provide personal guidance. It's like a funnel. You start with Ganit, the raw data of the universe. Then you filter it through Samhita to see how it affects the whole planet. And finally, you filter it down to Hora to see how it affects one single human life.
The structural design here is beautiful.
It is, but I have to jump in and play the skeptic again. I completely follow the math of Ganit. We just spent an hour validating the geometry of eclipses and retrograde loops, but jumping from tracking a 16-degree planetary shift to predicting an earthquake or a kingdom falling or a person's career, how does the text logically justify that massive, seemingly impossible leap from rocks in space to human destiny?
It is a massive philosophical leap, and it requires understanding the core premise of their worldview. You have to look at this with strict impartiality to understand the system. Regardless of a modern listener's personal skepticism regarding predictive astrology, whether you completely reject Hora and Samhita, the systematization of the data in the Ganit branch is undeniably scientifically rigorous.
Absolutely.
The ancient scholars did not view the universe as disjointed. They treated the cosmos as a fully integrated, seamlessly connected organism.
The Kalpurush, the cosmic being we talked about at the beginning.
Exactly. In their framework, the universe is a closed system of resonances. It operates on the philosophical and mathematical belief that macro movements in the heavens, like a planet shifting half a degree in the zodiac over a century, are inextricably linked via unseen physical or spiritual gravity to micro events on Earth. To them, the math isn't separate from the meaning. The math is the physical manifestation of the meaning. They believed that if you could perfectly map the gears of the clock, you could naturally read the time the clock was telling about the world below it.
The rigor of the math gave them total confidence in the rigor of the prediction, which brings our entire deep dive full circle. We started by exploring the idea that these texts view the universe as a cosmic being, and this intense, obsessive mathematical measurement of orbits, tilted angles, and line-of-sight illusions, the Ganit, is the literal eye of that being. It seamlessly blends rigorous objective geometry with deep unifying philosophy.
Really does.
Let's summarize the massive clockwork journey we've just mapped out. We started on the ground, establishing the Earth's 23-degree tilt, its 23-hour and 56-minute sidereal spin, and the invisible grid of the equator. We took that grid and violently projected it outward onto an infinite celestial paper lantern to give ourselves a mathematical anchor. We mapped the ecliptic, the sun's path, and widened it into the 16-degree multi-lane highway of the zodiac. We navigated the mind-bending reality of the precession of the equinoxes, watching the Earth wobble and the background stars drift by 50.29 arcseconds every single year, and we watched ancient scholars patch that geometric crisis mathematically with the Ayanamsha.
A true software patch.
We tracked the slingshot gravity of perihelion, observed comets boiling off gas as tail stars, and watched microscopic meteoroids ignite into atmospheric fire. And we finally untangled the complex optical illusions of the dome, the highway passing trick of retrograde motion, the blinding geometry of planetary combustion that hides Mars for 118 days, and the fierce fraction of a degree line-of-sight battles of planetary wars. It is a staggering, breathtaking testament to the observational patience and mathematical genius of early astronomers.
It truly is a monument to human intellect. They built an entirely functional, highly predictive clockwork model of the universe using nothing but naked eyesight, generational patience, and brilliant geometry. But as we wrap up this deep dive, I want to leave the listener with a final thought experiment. Something that isn't explicitly in the ancient source material but builds directly upon the mathematical foundations we just spent the hour constructing.
Ooh, I love a good thought experiment.
We have spent this entire deep dive looking outward from the Earth. Every single coordinate, every mechanism we discussed, the celestial equator, the sign tropical zodiac linked to our seasons, the visual trick of retrograde lapping, the glare of combustion, every piece of this math uses the Earth as the absolute, immovable anchor point. The Earth is the required center of this specific geometric universe.
Right.
But today, we exist in an era where we have man-made probes like Voyager 1 that have physically traveled beyond our outer planets and are currently flying alone through the dark of interstellar space. Imagine for a moment that you were standing on a probe completely outside our solar system, looking back at the tiny, distant speck of our sun.
Okay, I'm picturing it.
From that vantage point in the deep void, the ecliptic path dissolves. The Scion seasonal zodiac becomes meaningless. Retrograde motion and planetary wars vanish because those optical illusions only exist from the specific localized angle of a human standing on Earth. All these perfectly calculated Earth-centric coordinates completely evaporate. It makes you wonder, what would a completely non-Earth-centric mathematics of the universe actually look like? What invisible grid do you draw to make sense of the chaos when there is no physical ground left beneath your feet?
That is a beautifully disorienting concept. A universe without a center. Something for you to mull over the next time you step outside on a clear night. Look up and try to trace the hidden, ancient clockwork ticking away inside the scattered glitter of the night sky.